This is the Empower Podcast, released May 8th, 2022. Episode 588. Siloed Engineering with Leigh Brady. Welcome to the Amp Hour. I'm Chris Gamble of Contextual Electronics.
Hi, and I'm Leigh Brady. I'm an electrical engineer here in the Orlando, Florida area.
Hello, Leigh. How are you?
Doing good, thanks. How about yourself?
Yeah, real good. Orlando, Florida. My brain almost always goes to the Disney parks and stuff like that. Obviously, there is industry there.
Exactly.
But what kind of industry is there? Like, where are you floating around in industry right now?
It's an interesting place to be an electrical engineer. You're absolutely correct that Disney parks, Universal, SeaWorld, and various others are here. Although my understanding is that the majority of their engineering is done out in California. However, they do have people doing qualification and stuff like that here. And it's interesting because they tend to use things like ladder logic and PLCs and things that I'm not very familiar with, which is why I haven't been part of that industry. However, we have UCF here, which is a big engineering school, and they have a good optics program and a good electro-optics program. So they have something called CREOL, which I'm not sure I can remember the acronym, but effectively it's an optics center. So we have a lot of electro-optics here.
Cool.
One example was that you might have heard of would be Luminar, who are doing the LiDAR for self-driving cars.
Oh, cool.
And we also have a lot of defense.
Well, and I'm sure you run into people, working in Disney because, as they say, it's a small world after all.
Oh, indeed.
Terrible. That was so bad. I was like winding that one up for like a minute and a half there.
Very good.
Sounds like you might not be from the Orlando. You might not be an Orlando native. Is that a correct assumption?
That's fair to say. Although, if any of my past colleagues from the UK are listening, they'll probably be making fun of me for my perceived American accent.
Oh yeah, you've been.
Yes, I've been somewhat Americanized.
Yeah, exactly.
But yeah, originally from the UK and spent about the first 10 years of my career working over there in the defense industry.
Yeah. So I definitely want to get to that. We were kind of chatting before the show about, what we're going to cover here. Your background is like, it's great because it spans different industries and, kind of stuff that might not be. So like we talk to people on the show a lot about like open source and stuff that is kind of able to be talked about and people might know the names of companies like that. But when you start getting into defense and medical and stuff like that, it's just there's less out there because often they're trade secrets or, there's clearances and things like that. We're not going to talk about trade secrets or clearances or anything like that, but just talking about the industries themselves and where you've been kind of traveling through them.
Yeah, absolutely. So obviously working in defense in both the UK and the US, kind of through a partnership that not everybody realizes exists. The UK and the US have a partnership, which I believe is known as the Mutual Defense Agreement, whereby basically largely non-classified information and resource more than anything can be shared. So what that effectively means is that sometimes English engineers and UK engineers come over here and vice versa, and just kind of learn engineering more than anything else.
Yeah,
which is what I was involved in. It's very interesting to see how people do things differently in the US to the UK, and some of it's very, very similar.
Yeah, I mean, if you had to take like a high-level shot at what that difference is, I mean, what would you kind of start to classify it as?
I think more than anything, my perception at least, was that in the US, things tend to be driven to very specific specialisms. So you'll have your FPGA engineer, you'll have your analog design engineer, and so on. And they won't really expand too far outside of their box. And some of that obviously is an attempt to make sure that, need to know information and so on. But more than anything, I just think it's a cultural thing. So in the UK, I got opportunity to be more of a generalist, and I would consider myself to be a generalist as an electrical engineer. So I've done analog design, I've done some FPGA design, some systems engineering, and so on. And I found that wasn't the case over in the US. People tend to specialize quite early, even sometimes to specialize as early as an internship almost, and come right in, certainly as a junior engineer, as a junior FPGA engineer or a junior analog design engineer, and then follow that career path, which is interesting and obviously gives them
Yeah,
depth, but doesn't give them necessarily breadth. And I think you can make the argument that depth and breadth have their relative merits. So I think,
that's right. I think
yeah,
we've made that on this show many times, actually. Yeah, yeah.
yeah,
And one thing that from a personal perspective, I always see an argument against the depth first would be you kind of get pigeonholed, right? So if you have a deep specialization in, I don't know, like radar systems, then the knowledge is most certainly transferable. But from how hiring practices are, I feel like you're going to mostly be working on radar, in and around radar, for a good chunk of your career. And
right.
some people dig that, and and I'm sure there's good money in being a specialist like that, but there's downsides, and you don't get to see as much or experience new things.
I think that's true, and I think I was fearful of that. I didn't want to close myself off to other areas of electronics and electrical engineering too early. And also, I found myself, they say the change is as good as a rest, and I found myself, if I was working on more than one area of a particular project, I could kind of put one down while it was, giving me a headache, pick something else up. And that was a good way for me to manage that. Other
Hmm.
people manage it in different ways, but that was the way I naturally did it. And I think that's what kept me wanting to be a generalist.
Yeah, that makes sense. Yeah. I mean, is there kind of a so now speaking specifically about the defense industry, is there enough of a hump to get over in terms of like clearances and knowledge of the industry practices and stuff like that that would then maybe allow a generalist more than in just any other industry?
Not really, not in the US. I don't think. I think it's very rare to find a technical hands-on generalist in the defense industry that's right down in the weeds, designing the coalface, as it were. I think that's what's more normal to find is that those people that would be generalists tend to find themselves as systems engineers or engineering managers and
Uh,
engineering leaders. So they're
uh-huh.
they find that they're not happy. Just grabbing onto one thing, and they tend to lift themselves into a position where they can have that technical oversight. Maybe there'll be an integration engineer, for example.
Got it.
That's been my experience. Whereas in the UK, I was actually able to kind of do a project on a certain team, and then say, put my hand up to say I would like to move to maybe a different team and do something else, and that was possible and kind of
Yeah.
encouraged.
Interesting. Yeah, I mean, I I think listeners of the show will find no surprise in that I'm on the generalist side and I'm interested in the generalist side. I think I think there's a lot of value in empathy and cross training and stuff like that. But then you don't you might not have that super deep technical knowledge that you need for something like that. I wonder though, is the so you've experienced both sides of the U.S. versus U.K. Is there actually like a hiring preference then as well? So like, does that mean that if you are trying to apply for something at like a defense contract in the U.S., that you have to have that super depth of knowledge, or else you won't get the hire in the first place?
I think that can certainly be true, and I think it's more true the further into your career that you are. Obviously, entry level positions obviously have fewer stringent requirements because they're expecting to train you somewhat more. Although I do think defense in the US, just from my experience of colleagues that I know that have moved industries, will value other industries that have a similar structure. Medical, I think, is one of them. Automotive is certainly another. Anything that's got regulatory obligations, so anything maybe safety critical, which often transport
Ah,
is. So I think they're kind of looking for that experience. But something else that's interesting about the UK is that I've noticed that there's a big emphasis in the UK on more vocational programs. For example, the company I worked at had an apprentice scheme where they would take in not graduate students from university, but students straight from high school and train them for 3 years and get them qualifications in things like soldering, board assembly, mechanical assembly, machining, and so on. And some of those people would come out and be technicians in the company out of that scheme. And some of them would actually go on to get their electrical and mechanical engineering degrees. And I found those people to be some of the most valuable people.
yeah,
If you've got an electrical engineer that started out as an apprentice, learning how to construct systems from the ground up, they're very hands on, and then they get the
yeah.
theory as well. I think it's really valuable. It's something that I noticed that vocations like that over here aren't pushed as much. A lot of people just feel like they have to go to college.
Right, and then you don't have the reference point for why you shouldn't make a 1 millimeter plastic sidewall, or that part isn't machinable, or whatever the equivalent is. Right.
Right, and I'm sure this has been said before, but it's so surprising that This is the same in the UK, by the way. So surprising that colleges don't teach soldering or the use of lab
Yeah.
instruments. It's kind of assumed
Hmm.
that you're going to pick that up. But depending on what your project is when you're at college, you may not pick that up. You may you may decide to follow a coding type project and never go anywhere near a circuit board.
Yeah.
But then you may get a job where you're expected to do both. So yeah,
Yeah. I mean, yeah, I think, yeah, we probably talked about that many times. Maybe one of the most talked about things, in personal interest of mine, but I don't
yeah.
know if there's any solution to it. I mean, aside from maybe taking on an apprentice type scheme, like you mentioned, that would be a step in the right direction.
Most probably. I'd actually like to see colleges place more emphasis on parts of engineering that aren't just theoretical. I realize they have finite time, but there's not a lot of emphasis on the design cycle. There's not a lot of emphasis on the V curve, the systems engineering V curve from requirements through to detailed design and back to verification and validation.
I don't know if I know that term, V curve.
The V curve. So this is a system engineering term that I think gets thrown around a lot in defense and certainly also in my current role, whereby if you imagine systems design as starting at the very highest level, a top-down approach, as it's often called, you define requirements at a very high level. Let's say we were designing, the classic example of a swing for a child or something. The swing must be of a certain height from the ground. The swing must not be able to reach more than a certain height when it's swinging, and so on. But you can imagine that taking that and then deriving lower level requirements from that. So, okay, well, if it must be this height from the ground, then is it going to stretch when they sit on it? And if there is, then that is going to impact the requirements for the kind of material that holds the swing to the tree. And you could go all the way down to tensile strengths of materials that you're going to use as a design specification. So that's sort of like the downward path of the V. So we're now at the bottom of the V, if you can imagine a V shape. But then you need to validate up. And so you start climbing the hill. So you would validate at the lowest level. Okay,
Oh yeah.
I've bought tensile strength of this, so I know my cable is this, and I'm going to test it on a pull tester, all the way back up to I've now built the swing, and I've put my yardstick, if you're in the US, or a meter stick next to the
Anywhere else?
swing,
Yeah, yeah.
exactly right, and check that it's the right height. And that's sort of like the V curve of validation.
Hmm, that's great.
Yeah,
Yeah, I'm surprised. I mean, I could picture it all in practice, but I just never heard the term. So that's good. That's a really
right.
good term to have in the old noggin rattling around. So that's good. And when you say system design, system engineering rather, how do you define system engineering?
Well, I think it's a process, and I think that that's the biggest part of it. If you're following a process, it almost doesn't matter if your process is quite bad. At least you're going to have consistency, and I think that consistency is what differentiates engineering from design. You could do a great design with poor engineering, and it's not very reproducible.
I guess maybe a different way to say that is, who is a system, like, give me a project example that, like, what is the system engineer in a project normally doing? Because I don't usually hear that term, but I assume that is a person, right?
It is a person, and classically, they would be responsible for gathering and writing unambiguous requirements. But not only that,
Right.
that would be their role in one aspect of the system design. They're
Got it.
often also involved in integration, closely with the integration engineer and the
Got it.
validation to design the tests. So it's kind of a systems. I mean, kind of what it says on the tin, but it is a systems level look at the design to try and make sure that everyone's talking to everybody and that everybody's deriving their requirements in a cohesive manner, and to deconflict requirements, of course, as well.
So I guess what is the scale of that? Because okay, so I think about it like so if we're in a military company and I'm designing a fighter jet, there might be a system design engineer for the entire jet, but is there also one for like subsystems, or like how small of a what is the atomic unit of a system engineer? Is it like a circuit board? Is it a component? Is it a assembly? Where does that line usually get drawn? Especially in military.
I think, like everything, it depends. It depends on the scale of the project.
I know, just make something up here
Yeah, right, right.
though.
But typically, you're right. You will have one or two systems engineers to every, I don't know, 5 or 10 design engineers would be my guess. Really, that it's because they're not necessarily doing the hands-on work, but they're more the glue that holds
Mm.
everything together.
Yeah. Yeah. I mean, like, I think about past experiences in product companies, and sometimes that would be called a product engineer, product marketer, depending, if they're doing externally facing. product manager. It depends really, just kind of, it's just like where you're drawing the lines, and kind of like the norms within different industries. So it sounds like it's kind of a mix of all those things in the defense industry.
It is, but I think the thing that would distinguish a project manager or a product engineer from a systems engineer is the systems engineer is typically very technically astute.
Uh-huh.
So they're very aware technically of all of the various aspects of the system.
In a hands-on way as well. Do they need to be able to walk out to the manufacturing floor and be like, I can run this through its paces?
More accurately, they need to be able to ask the right questions to someone on that floor because, especially in
No.
defense industry, you know that there's
It's like,
so many
well,
people
sir,
in.
this is a high power explosive, so please don't run it through paces right now.
Right,
Yeah.
right.
Yeah.
But you can imagine that there's loads of people in a team doing very specific roles, as I said before.
Mm,
That's typically another thing that I've noticed. The teams are huge in defense. I mean,
mm.
if you pick a classic kind of program like the Joint Strike Fighter, I struggle to
Yeah.
guess, but I imagine there are hundreds, probably thousands of engineers that
I
have
would have
worked
guessed
on aspects
1,000.
of that.
Yeah, that's
Yeah,
the F-35. That's and other
right.
sub variants of that, right?
Right,
Yep.
and I mean, and that's just one aspect of it. You know, that's just to say the engineers, and that's not really necessarily including all of the support to the engineers, like project management, leadership, and so on. I mean, it's phenomenal, almost unparalleled. I don't know that. I would wonder whether maybe
Well,
Apple.
that some people refer to that as a quagmire as well.
Yeah, yeah,
That particular program is like, oh yeah, but
yeah. Well, we could talk about that, but my
yeah, yeah,
opinion on that. But yeah, I
right,
think
right.
that's trying to fit a good example of where you probably should design more than one system.
Yeah, yeah, right. No, exactly, exactly, right. That is something where, I mean, and that also kind of felt like, so. One thing that I hear in like defense contracting or the defense industry as well, I start to think about like just like massive waterfall charts, and massive project overages and delays and stuff like that. I mean, how true to form or fair is that stereotype that I have in my head?
It can be true on the programs that are very public and very large, like
Mm,
development of new fighters and development of
yeah.
new weapons and so on. But I'm sure you're aware that there also exists smaller programs.
Oh, totally. Yeah.
Yeah, and I think Lockheed referred to them as IRADs, internal research and development, and
Okay.
those are typically much smaller because and probably have smaller budgets because they're research and development. But like all research and development, it tends to be more fun, a little faster paced with a little less restriction. Obviously, when I say less restriction, not pertaining to safety. That's
Yeah.
the only thing,
Yeah.
but pertaining to things like programmatic requirements and so on,
Yeah.
and some of
Right.
the high level red tape. Some of that goes away, so those can be fun to work on.
Yeah. No, that would definitely be the type of stuff. So I mean, so you did work at Lockheed. This is part of your borrow an engineer program. Is that right?
Yeah, I was at Lockheed learning systems engineering, basically the systems design lifecycle.
Oh, cool.
Yeah,
Yeah.
which
Yeah.
was really really fun.
Yeah. So you were hands on. You got to see it. That's great. That's
Yeah,
great.
yeah, exactly.
And you worked. I mean, this is partially nuclear stuff as well, or is that a separate role?
Not at Lockheed, no. So
Okay.
the nuclear stuff was in the UK, and
Oh,
also I
okay.
spent a couple of years at Sandia National Labs, which was good fun as well, where I was qualifying or designing tests to qualify an ASIC that they had made, which was for it was basically if you can imagine that you might want to create a chip that would basically be a logic analyzer or a system monitoring chip so that you can make measurements of systems.
Hmm.
And so mixed signal chip, which is quite interesting to qualify with analog, obviously, and digital aspects on there.
Yeah. I mean, for all these things already, like you're so like we talked at the top of the show about like having a broad basis of engineering knowledge. Like there's already like a bunch of stuff in here that's like, wow, okay, yeah, that's a lot of different roles, and mixed signal in its own is it's a couple different things there. What is your preference in these spaces? FPGA versus ASIC versus analog. Where do you find your happiest times?
I think I've got a fondness for analog design, and I mean that in the sense not chip design. I have no idea how to do that.
Hey, same.
Op amp type designs, small signal analog front ends, that kind of thing.
Got it. Yeah.
And I think I like it most because it's kind of challenging. and there's so many things that can go wrong.
Right.
That
Unlike FPGAs that might control nuclear explosions.
well, it's more to do with how with an FPGA, I guess things tend to either work or they don't, and the bugs can still be hard to find. But I like in analog how you can find. Well, I guess it's the analog nature of analog, right?
Right. Right. Right.
There's lots of gray areas in there where
Right. How many ways can things goes wrong? Infinite ways.
right, or but more accurately, how right is it?
Right. Yeah, that's true too.
It's
Yeah.
sort of working, or it's
Right.
working better.
Yeah.
Whereas with I think with digital, it's kind of it's working or it's not working,
Hmm.
more or less. Maybe oversimplification, but
Yeah. Sure. Yeah. Yeah. I mean, a spice simulator is a lot different than a logic emulator, right? But
right,
both are very, very valuable, and one might give you a slightly more definitive answer. I'd probably trust a logic. They're not called emulators or simulators, right? Like for doing
simulator,
a
yeah,
yeah, right. Yeah, I'd probably trust that a little bit more than my spice models.
yeah. But like everything, they're only as good as you. The model's only as good as what you put in, and I've seen plenty of examples whereby an FPGA design will simulate. I mean, the classic one is metastability. If you don't take account of metastable states in your design, your simulation
Mm,
will probably work fine
mm,
because it's not very good at simulating race conditions unless you're simulating post synthesis,
right,
post place and route. But most people, I say most people, that's probably unfair. A lot of people don't simulate that way. A lot of people simulate the design just
right.
from the VHDL or Verilog.
Yep, yep. They want to see like very, very square waves, and
Right.
then what does that square wave decode to? And then it does decode, and you're good. And
Right, but
it's
if in your simulation, if you have two clock domains and they're always
yeah,
synchronous,
yeah, yeah.
but in reality they're not synchronous, then
Mm-hmm.
everything just went off the cliff, and
Mm.
your simulation will never fail. So that's a classic one that a lot of people get caught up on when they're in their junior years, and I know about it because I did too.
Yeah, right, right. Who
So,
who dat? That me.
right.
Yeah, yeah. No, same there. It hasn't. It's been a while for me for that stuff. So I mean, it does seem like FPGAs kind of carry through your career as well. I mean, is it just kind of a tool in the toolbox at that point, or just because they're such specialized things? I mean, it does. I do think of like when I think of super high end FPGAs as well. I think of defense industry because it's like might have been an ASIC, but you're only making 10 of them, that sort of thing.
Yeah, there's a lot of reasons why defense industry would go towards ASICs versus FPGAs. The space industry is a classic one, actually, which I guess kind of plays into defense. So you may be aware that exoatmospherically there are charged cosmic rays and particles that can cause problems with electronics.
I actually blame not only my electronics problems on them, but all my personal problems too.
That's right.
Like, oh, no money in the bank account? Cosmic rays.
Yeah, it's almost always cosmic rays.
Yeah, cosmic rays.
But yeah, notwithstanding that Superman has got his eyes on your bank account and is playing with the bits in there, yeah, you've got the issue of what they call single event upsets, which is a cosmic ray coming blasting through the crystal lattice and flipping a bit. And you can kind of try and take account of that if you're doing things like CRC checks, but in real time, it may be a transistor that isn't really involved in data. It might be a transistor that's kind of part of a MUX or something like that.
Yeah.
So, how do you know
Oops.
what's going on? Right.
Yeah.
So if you make an ASIC and you use a technology that's large, which is kind of like archaic to us,
Mm.
now we strive for small gate sizes, right? But
Mm.
if you have a bigger gate dimension, then comparatively that particle is smaller. And so when the
Mm.
statistics are, there's not going to cause so much of a problem.
Right, right, right. More energy to knock more electrons into different states or whatever it is.
Exactly. But then the
Yeah.
other option, which is much cheaper than an ASIC, is a lot of FPGA vendors will offer what they call triple modular redundancy, where you can. I think at one point it was native to a specific vendor, but I think it then became offered by others. Basically, you do your logic design, and then you click a nice button in the tools that says "Give me triple modular redundancy," and what it does is it sets up 3 copies of the design in
Oh,
the
really?
FPGA, and then
That is
and
a
then
specialized button.
right. But not only that, it links it to voting logic. So you get 3 copies, and whichever 2 agree, that's the one that it goes with.
Wow. And that's just like a macro that like gets generated?
It's kind of part of the tool set. So just as
Ah,
the synthesizer synthesizes the design and then place and route, unless you want to get into placing on specific cells yourself, which you absolutely can, and all the tool sets let you do that. But if you just say, hey, do your best, fit this design in my FPGA
yeah, yeah.
within my design constraints, there also exist tool sets that will do the triple modular redundancy thing for you and say,
Huh.
okay, we'll figure that out and make sure that it works, which is, yeah, it's amazing.
Yeah, that is very, very specialized. Yeah, yeah.
Yeah.
So that's another interesting kind of, so we've had FPGA people, of different areas. I did a very, very long time ago. Dave did a long time ago, but then also we've had people on who've done it professionally, maybe at high levels, and then maybe people doing like Zinc stuff and whatever. But then we've also had the open toolchain people on here, and one thing I've always heard is like, look, open toolchain's cool, I like it, but these kind of like high end, bleeding edge type of triple modular redundancy generating type of systems, it's like that's just in the vendor tool chains because that's what you have. You're just on the path that the vendors are targeting because they're driving their software development by Lockheed or whomever they're is driving their software development.
Yeah, I mean, that's absolutely true. Obviously, companies as large as the defense industry are going to be huge players in driving the requirements of what they want to see in the chipsets that occur.
It's to the point where even I remember this is probably not actually related, but maybe a little related. I remember Xilinx ISE, which I used gobs of years ago, almost 20 years ago at this point. But the CD installs all had F16s on every CD. There were like 10 of them, of course.
Right.
Like targeted branding, even. It was like, oh, okay, yeah, well, we know what this is for.
Well, I mean, the amusing thing is that Xilinx ISE is most likely still used. Well, I know I've used it as recently as a year ago because a lot of the FPGAs that are still in production, such as the Spartan 6, are only supported under ISE.
Oh,
Well, and it's either that or you go pick a third party tool set and buy a license for it, which I believe is probably what the defense industry will do. They'll use Active HDL and Simplify and all those other good tool sets. But if you're in a smaller company like I was, well, the free tool set's free, so
yep,
we'll
yep,
we'll use it.
yep. Right. Well,
um,
and longevity. So I guess another constraint of the industry would be this kind of longevity, right? Like defense, you need 20, 30-year type of supply contract stuff.
exactly, and actually, if you that's a really good reason to network with if you're not in the defense industry, but you are using technologies that you're worried will become obsolete, or especially in light of recent events.
Bubblegum tap shoes.
Right. It's really good to find out what's being used in defense because of the longevity of the programs. So it's my
uh,
belief that one of the reasons that the Spartan 3 and Spartan 6, I mean, the Spartan 3 went end of life this year or last year, I think it's this year. It's my belief
uh,
that that's probably because it's being used in big defense programs. And,
uh.
and
Wait, are you saying though? Are you saying that so a design engineer listening right now should use Spartan 6 because of that?
no, I'm
Oh,
saying that they should find out what their industry is currently using or trying to design
uh,
with, which would probably be things like Spartan 7 and Zinc and so on.
uh,
And notwithstanding that they would go, it's not just Xilinx, of course. I'm sure that they'll be using Intel
sure,
FPGAs and so on.
sure.
But if you know someone and they're saying, oh yeah, I'm doing a design on a Spartan or I'm doing a design on a Vertex or whatever. If you know that they work on in a big company, not just defense, but a company like Apple or any of the really big companies, it's most likely they're going to stick around because
Yeah.
why wouldn't a manufacturer keep manufacturing the
Right,
chips, right?
right, right. Yeah.
So
So the thing I was going to say there is that I've always kind of talked about like chasing the most popular chips, right? I think that is probably a better bet than something that might get end of life, especially if you have your own long term type of stuff.
yeah,
However, the thing I wanted to call out with defense contractors is that there are, I forget what it's called, but my buddy's a purchasing agent at a defense contractor, and there's something where like they get to jump the line basically. There's like it's kind of moot right now because everybody's trying to jump the line, but like there is actually something where if you have in the US at least, you can get like a bypass because you're making critical defense infrastructure type of thing. And you'll
yeah, I think that's definitely true. I mean, I don't have a
yeah.
lot of experience with that, but I think that is absolutely true. And obviously, consumer electronics don't get to do that, but
Right,
it's
right. And
still
yeah, that's what I'm saying is that in the tough times like we are now, which, that would be an additional thing where it's like I would, as a small player, and then also, a non-defense player, I would be truly the back of the line, and that would almost be like a antithetical to that idea of designing in a popular chip that might be, might have that longevity.
Yeah, I think that's true. And also, I mean, I might even rescind something I said a few minutes ago about Apple being a good example because, of course, they do their own fab and they make their own chips.
Yeah, yeah. See, I think that actually is a good one though for well, maybe. I don't know. I remember like chasing like sensors that were on phones and stuff like that. I think that then ends up hitting the secondary market, and usually vendors might not make that, so a sensor vendor might not make it for 30 years. But I do think once they have the IP developed, they might say after, Apple moves on to the next hot thing, they might say, well, we've got all this IP. Can we spin it out as a publicly available part now? Like I'm sure some of the sensors that I use have been, developed for big companies in the first place.
Yeah, I think that's true. I think also I've had experience whereby working in a very small company, startups and small companies can be kind of kept out of the market if a big company is more lucrative to a particular vendor.
Oh yeah.
And I've got experience of trying to develop for specific chips from very well known companies where the very well known company plain old wouldn't sell to us, wouldn't give us any data sheets.
Wasn't Maxim? You could say it's Maxim. It's cool.
No,
We've
no, it
we've
wasn't.
said it many times on here. No,
It was actually it was one of the larger Japanese manufacturers of image sensors, but
mm.
the problem being is that you can't get the data sheets either; they're all proprietary.
Yeah, right.
So the path that smaller companies have to take is to go to a third party that's an authorized reseller, but then you're kind of again kind of stymied by that. So not only are you a small
Oh, you're
engineering
just
team,
waiting at the drip feed, basically. We're all just, we're just waiting for that tap to turn on, and it
right?
may
And
never
you're a
turn on
small
again.
engineering team, so and you're trying to compete with larger engineering teams that have better information. It's quite odds can be stacked against your favor in some respects there.
Yeah,
So
yeah.
it's
It's
difficult.
it's crazy, yeah. And actually, this was kind of an overarching theme that we want to kind of talk about as well, just kind of big versus small. You've been on both sides. You've been in very very large defense contractors. You've been
Mm.
in small manufacturers. Are there other big versus small type of things that you've seen that you like, don't like? I mean, that's obviously one.
Yeah, I mean, I think everybody. I won't necessarily dwell on the obvious. If you work in a very small company or a startup, there's almost no red tape, and R and
Oh yeah,
D
true.
can be as
Yeah,
fun as you want, right?
yeah, right.
And especially if it's a startup that's managed to get some good investors, then you've got a nice big budget, and it's kind of it's kind of like a sweet shop, really, or I should
Hmm.
say, a candy shop.
Both are acceptable here. If there's candy involved, I'm into it. I don't care what it's called.
But obviously, then in the larger companies, you have access to big budgets. You have access to leverage, as we discussed, so you get better support for what you're trying to do.
Yeah, yeah.
For example, there's certain designs that I've been involved with where you can go directly to the tool manufacturers and have their engineers support you, even
Hmm.
pay them a retainer to kind of develop specific IP or something for you for your specific project, which you just kind of have to model your way through if you're in a smaller company. But then in
Yeah,
a smaller company, I think is good for the generalist because you get to, the classic wear many hats, which is probably a poor way of saying it, but you do get to turn your hand to lots of different things, some of which are not even engineering, which can be
yeah.
awful to
Good,
people
good or
that
bad,
don't like that.
right?
But yeah, good or bad, exactly.
Yeah. I actually maybe I mentioned this last week. I looked up a Jira video on YouTube the other day, and I was like, oh, this is a momentous time in my life. I just looked up how to do something in Jira on YouTube. Like this is where my life is right now.
Yeah, I think that most non-engineers would be absolutely aghast at how frequently engineers consult YouTube
Yeah,
and
yeah.
Google to remind themselves either how to do things or to do things that they
I
don't know
just
how to
gotta,
do.
just gotta get like, like the pull cord on like a lawnmower. It's like that. I just need the pull cord, and then I can, dive down a rabbit hole or whatever it needs to be. The motor's kind of purring. Then I'm happy to go. But yeah, sometimes you just,
The classic joke, isn't it, of the guy comes along to fix the engine and smacks it with a hammer and it works, and he charges an extortionate bill,
yeah,
and he goes on to say that the actual reason for the bill is that he knows exactly where to smack it with a hammer. Well,
that's right.
I consider that I spent 4 years in college learning exactly what to type into Google to figure out what I need to do.
Yep, yep. Well, that's an important one too. As long as Google's available. uh,
It's true, right?
yeah, yeah. So we were kind of talking about big versus small. I mean, is that kind of the? I mean, so I guess do you have a preference? I mean, you're back kind of in the big world? It feels like. Are you missing things from the smaller world now?
Not really. It's interesting. I think that there's a middle ground, a Goldilocks zone.
Mm-hmm.
Typically, you find that
It's like you're at a company of like 150 people, and they hire the 151st. You're like, I'm out. This isn't for me
right,
anymore.
exactly. I mean, I think where I am right now is kind of nice because you tend to find that some companies go around buying up other companies, especially startups or
Mm,
smaller companies that have reached that kind of critical threshold. And I feel like that's where I am now, although the company it's been a long time since it was acquired. But it still has that feel of like a smaller team with a specific
mm,
goal, yet you get the support and the good parts of a larger company. Obviously, you get some of the bad parts, some of the red tape. But
mm.
yeah, I think it depends on really the kind of person that you are. But I think every engineer should probably do a bit of both. You know,
Yeah, that's good advice. When in their career should they do any of these?
well, it's my belief that it's better to do it the way I did it, which was an accident when I did it. So I went for the large company first. But the reason I think that that's a good idea is because large companies have many, many opportunities within them.
Yeah, yeah.
Often they have graduate schemes. I was actually on a graduate scheme
Oh, interesting.
when I
Yeah.
came in. So, a specific scheme geared towards exposing new graduates to different areas of engineering so that you
Hmm.
get to figure out what you like and what you don't like and what you're good at and what you're not good at.
Yeah, the grand buffet of engineering specialties that you could snack on.
Right. I mean, and it's probably no surprise that, many engineers come out of the graduate scheme saying, "Oh, I want to be a project manager. Don't want to be
Yeah,
an engineer."
yeah, yeah.
Well, that's
Right,
great.
right, right.
Okay, that's fine.
Right,
That's
right.
good.
Better to know that up front than to spend 10 years or 20 years miserable as an engineer and like be like, and then, and, or even in a spin that much more positive sense, like, they have a aptitude for project management and they're going to be a great project manager. That's actually even better. Right.
Exactly. The other good thing about large companies for younger or more junior engineers, less experienced engineers, is that they have large budgets and almost always have a training budget,
Yes.
which is specifically meant to be spent on developing people and making them better. That's not to say smaller companies don't want to do that, but if it's a choice in a smaller company between developing the new product or spending 20 grand training 3 or 4 engineers, most often they'll want to develop the product.
Yep.
So I think you can really bolster your resume and get good experience as a more junior engineer in larger companies if you do that right out of college. But I think 10 years is your limit to get out. And if you don't
Yeah.
really get out, then you're not going to get out.
Yeah.
that's,
Yeah.
that's kind of the problem.
Yeah, another one in there. I am in agreement with you on this. I'd say the other one that's in there is probably kind of tied into what you're saying here is the mentorship aspect. And like usually, there are formalized mentor programs, but I think it's just being able to, in big teams, you're going to experience a lot of people, different personalities, different archetypes, different people you may or may not want to hang out with after work. But I think you can almost always you can learn things even in the worst case scenario of like that's not the kind of engineer I want to be,
Right.
or I'd rather have a different outlook on life or whatever. I think that is a large piece. When I hear people coming out of college and then saying like, "Oh, I want to go straight to a startup," I'm like, you're going to get a lot of really cool experiences like that, but you're not going to have then you're going to be a little bit more in the open for trying to find a mentor or someone to lean on, and you pay for design reviews. You just have to work harder. It feels like on that, on like building your rails basically to make sure you don't proverbially go off them.
Yeah, that's definitely true. And the individuals that I've observed that have come out of college and gone into startups or even tried to start their own companies, the ones that were successful they just weren't like us mere mortals. They were extremely gifted engineers,
Mm, yeah,
and they were gifted not just in engineering, but they had business acumen, and they seemed to have a almost sixth sense for being able to figure out where they should go, what they should do, and what they should learn
yeah,
next.
yeah. Yeah, we had Phil on from Phil Salmony from Phil's lab, and I feel like he's very talented younger engineer. Went out on his own pretty early, but even he kind of expressed the same thing. He's like, how do I find people to work with? I think he is designing that for himself now. and he's already a very talented engineer. I'll link that show in too. But yeah, it's a tough thing. I think it's just you have to understand that you might be kind of jumping in the abyss, and there's some excitement there, but it could be also frustrating.
There is, and it's interesting you mentioned the mentorship aspect because you've reminded me of another quite big stark contrast between the UK and the US that I noticed at least. So in the US, I'm sure you're aware, we have the professional engineer, the PE, which you can study
Yeah,
for and get, but most people don't really do that unless they're working in some aspect of civil
yeah.
engineering.
In power engineering, I feel like, and building
Right,
engineering for
exactly.
electrical. Yeah, electrical versus electronic. I feel like.
Right, that's absolutely true. Well, the UK equivalent, and I'm not sure it's really an equivalent, is the chartered engineer, and chartership is much more different to that. I was a chartered engineer when I was over there. I actually haven't
Yeah, yeah,
maintained it.
yeah. I'm an EIT. I never went for a PE personally.
Right, and it's basically, as you said, like an organized mentorship thing, but they split it into five aspects, five different categories to do with obviously technical proficiency and use of innovative technologies, but also interpersonal skills,
Oh, that's nice.
designing with environmental, designing with your impact to the environment and the culture and the people around you. So they
Huh.
tried to make it very holistic. And in order to become chartered, you have to be mentored, submit your intent to be chartered, and then it's not an exam. It's done via interview where you present work that
Uh,
you've done and kind of show that you've actually done stuff on the job. So it's much more geared to show me you're an engineer now, not can you pass another exam.
I like that. Yeah. Yeah, I like that. I mean, it's tough because it's subjective then, right? And there's, probably a jury or equivalent, and there's always stuff with that, potential politics or whatever. But I think it has the most flexible outcome because of, the work that you're doing specifically versus like knowing the load forces on a pulley system.
Exactly, yeah, and it's about trying to further the profession
Right. Yep. Yep.
and make sure that the profession is generating engineers that are conscientious and are designing things that are going to be useful to people, but also are not going to be harmful.
Huh.
Which I think is a good idea. It can. I think it does an excellent job of not straying too far into what might be considered kind of hippie kind of tree hugging ideas.
Yeah. Yeah. Yeah.
But it
Yeah. It's
does
still
do
rooted in
a
reality. You're saying it sounds like.
right, right.
Yeah.
It stays in the right side of that and just says, well, what are you actually doing when you're considering your designs? What did you do to make sure that have you thought
Yeah.
about how this
Yeah.
product is going to be disposed of and the electrical waste is going to generate, and so on,
Hmm.
which I think is very important.
That's great. That it would be if people are listening and they know similar things in the U.S. I would love to hear about it. I don't think the PE is that. I don't. I mean, there
It's
are
not.
very
No.
important reasons for the PE, but not
Yes.
not not that. Maybe we could start something like this.
Yeah.
What do
I
you think,
mean,
Lee?
it'd
Should
be
we should
nice.
we start a U.S. based standards potty? Ooh, that's
Exactly.
exciting.
I'll ask the IEEE if they want to give us some money to do so. Yeah, it'd be
Oh
great.
God, yeah, yeah. Like, well, please submit a 45,000 page paper and
In triplicate, of course.
yeah,
Yeah.
of course, yeah, yeah. Oh man, yeah. Okay, well, I also wanted to talk about. So we kind of danced around it a little bit, but I think our first guest who's worked. I mean, so defense is not a super common thing here, but specifically nuclear in the defense industry. So what's that like?
Nowhere near as sexy as you might imagine.
I actually didn't. I didn't. Frightening is probably the thing I would say, and then probably bureaucratic would be another. I would assume, but
Yeah,
yeah,
heavily regulated industry, obviously. Probably the most regulated industry I could think of, and I think that that's a good thing. It's not in any way really dissimilar to other aspects of defense apart from the heavy regulation. And it's very interesting to see how you go about designing something to be very, very safe. So I think it has a lot of parallels with other safety critical systems like self driving cars
yeah,
or transportation. Because obviously, one of the ways that safety critical systems are designed, especially if you design to the IEC standard 61508, is that they are assigned a safety integrity level. And I think from 1 to 4, with 4 being the highest, and the level that you assign is dependent entirely upon the consequence of something going wrong.
yeah.
And so obviously you can imagine nuclear weapons industry, the consequence of something going wrong is very, very high.
Yeah, I feel
So
like actually that's a good point too. I should have said I said nuclear, but we're talking nuclear weapons here. This is especially like this is a little weird. I mean, this is a little odd for Amp Hour. I think this is. But
Yeah, and
how do
and
you
it's
feel about it? I mean, like you're not in it anymore. So what was your take when you were like moving into this space?
yeah. I mean, I kind of honestly applied for a bunch of jobs at a job fair, and this was one of them, and this is the one that fruited. It was good. They don't just do that. You learn about a lot of different things, and you work on a lot of different aspects of stuff. So a lot of the industry is also geared towards non-proliferation.
Sure. Yeah.
So you have to. There's a lot of work that goes on into verifying non-proliferation, which is very difficult because you imagine how do you go into even if it's a friendly country and they say we don't, we haven't got any nuclear weapons and we'd like to verify that, please. And they say, well, we don't really want you
No,
looking
no,
at
we
our
promise. We promise.
right,
Pinky
exactly.
swear.
So it's lots of interesting ways to do that and technologies surrounding that. But yeah, it's a I do think that it can be looked at in two ways. Obviously, these things are incredibly destructive. It's an odd place to work when you go to work every day hoping the thing you're designing or working on is never going to be used.
That's right. Yeah. Yeah, I mean, I've kind of heard of I mean, when I've talked to other people in the defense industry specifically, they always focus on defense, right? It's never offense. Some weapons are used offensively, and that's neither here nor there. But it seems like from a kind of a mental survival kind of piece, like developing these things, it's like, well, we focus on the defense piece, and then how they're used is how they're used.
Yeah, I think that's true. I think it would be churlish of me to say I never had any kind of thoughts or inner conflicts about what I was working on. But the UK push, they don't even call them nuclear weapons, they refer to it as the nuclear deterrent.
Huh.
And the idea is that it is a deterrent. I suppose it's kind of the idea that I'm sure you've heard of mutually assured destruction. The idea that if everybody who could possibly hurt each other has the means to hurt each other, then no one will hurt each other, which is
Right.
kind of a weird way to kind
Indeed,
of
it is mad, mad man,
yeah.
mad world, right? Yeah,
And I totally agree with that.
yeah,
That it
yeah.
is kind of strange and it is kind of mad. But then
Right,
there is the statistic, of course, since the Second World War, and there haven't been any wars between nuclear powers.
right.
Um,
Yeah, I mean, honestly with the Ukraine, we're right back in this too, right? I mean, like that.
right.
It's interesting, not interesting. It's sad and terrible. I mean, honestly, it's breaks my heart every day. But like, I don't know that would have happened if it was like Ukraine used to be nuclear and now it's not. They gave them up and whatever whenever that happened. So it's kind of crazy like that. It's just
Well, I'm not sure
how
that
it
the
impacts
Ukraine
things.
ever had nuclear weapons. Maybe they did. I'm not sure.
No, they did as part of like from what I
Oh, when they
remember
were part of
reading
Russia.
from when they were part of the USSR, they had
Right.
weapons. They gave them up based on a trilateral treaty between I think the UK, US, and Russia,
Right.
saying that there would never be any kind of action against them. Yada yada yada, and not so much. But I mean, so just as like here's the real thing. I didn't think prior to 3 months ago, whenever the Ukraine aggression started, like Russia aggression against Ukraine, I didn't have any fears of nuclear war, right? I mean, like it's always been an ever present threat, but I it's never like as an adult thought like, oh, I might die in a atomic fireball tomorrow. But like those thoughts came back, right? And it's just like, and but there is this piece like you're talking about that prevents it, which is crazy in its own right.
It is. I think it's definitely an odd time to be alive, with all that's gone on in about the last 2 or 3 years. But I also am comforted by stories that I've read of instances during the Cold War when
Mm.
the control room in Russia,
Yeah. Yep. Yep. Yeah.
you've heard about this, had lit up and
Yep.
was indicating that to all intents that the US had launched a nuclear attack, and obviously it was malfunctioning. And the person in charge of that decided that they would not retaliate,
Yeah.
even though they had the means and the authority to.
Yep.
So just because there is one crazy guy at the head of a government, I like to think that there are at least a few people in the chain of command that aren't as crazy.
Yeah.
But maybe it's wishful thinking. Maybe it's my way
I
of
mean, yeah. Yeah.
going about my day.
Yeah. Right. 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 Okay, so now there's obviously a large ethical kind of piece there that we were kind of talking through a little bit, but I get what you're saying. I mean, I hear you on these things.
Ethics is important, and I don't
Yeah,
expect everyone to agree with that either.
yeah, yeah.
Yeah.
On the internet, Lee? What are you talking about? Everybody agrees on the internet. I mean, it's
Yeah,
crazy.
that's true. That's very true.
So then, okay, so then boots on the ground, designing this stuff. I mean, did you ever? So you're developing like embedded systems around it and stuff like that. How much? How do you even do field test, like testing? Like, how do you test this stuff?
Well, the electronics control systems can be tested standalone because they're very much like any other uh, electronic subsystem, right? You just you create test boxes and you have the expected inputs, the expected outputs, and
Mm,
so that can
yeah,
be tested. In terms of actual nuclear testing, no nuclear testing has gone on for a long time. Certainly not while
yeah,
I was in the industry,
yeah.
and it's all done in simulation.
Huh? Yeah.
So there's lots of modeling goes on, and there's actually a large one. I think the certainly the UK's biggest laser. I think it might be one of the biggest in the world near Reading in the UK, which generates incredibly hot temperatures and is used in academia in the UK to
Mm.
study fusion reactions and so on, but also
Mhm.
can be used
Only
and
30
is
years
used
away. Only 30 years away.
exactly, yeah, and so they use that too for improving the models of the weapon systems as well.
Yeah. So to tie back in the systems engineering piece that you talked about, then, so we don't need any specifics, but like, what gets pushed down the chain? Is it like, is there a new specification of like we had X last year, 5 years ago that we designed and deployed. We now have to do Y, and the improvements are Z. Is there like, are there high level dictums like that that someone's coming up with some kind of like better mousetrap to use a terrible terrible allegory?
Kind of, but the timescales are vast, in the order of 30 or 40 years for developing new systems,
Oh
depending
wow!
on,
Oh wow!
yeah. More often than not, it's things like an upgrades in the terms of just things degrade over time,
Oh sure, sure.
right?
Yeah.
So that kind of thing,
I guess
parts,
sourcing, like we talked about earlier, like
exactly,
can't get this part anymore. We need to
e-
redesign the system, that
exactly.
sort of thing.
And requirements come down from ultimately the government in huge, great big swathes of paper that then get disseminated and digested and broken down.
Last question, a cheeky one before we move on to your next stuff. Did you ever wear a white lab coat? I feel like it's kind of a requirement as part of
It's interesting.
awakeness.
I don't think I did. And here's what's kind of
Uh,
funny. What I discovered in that industry, all the scientists wore lab coats and Metallica t-shirts, and all of the engineers wore suits and ties.
Interesting, huh?
Yeah.
I mean, good on the scientists for first off for having metallic underneath. That's interesting.
Yeah, I kind of veered more towards the Metallica t-shirts, and in some
uh,
respects was not well received. Uh,
uh,
but but yeah, it's kind of funny.
yeah, that's
And
great.
so yeah, British engineer suit and tie and jacket, US engineer chino and polo shirt.
Yeah, yeah, that fits my experience as well. Well,
Yeah.
actually, I don't know if I know too many UK engineers, but at least the I can verify the US version. So
Right.
yeah. Okay, so you've moved on from this industry. You've moved actually to different industries, and I should mention you were introduced to the Amp Hour by Carmen Parisi, past guest of the show and former host of the Engineering Commons. You guys work together at Wasatch. We talked about that a little bit, but that's a photonics company, right?
Yeah. Yeah. So Wasatch Photonics, where I met Carmen, is a spectrometer company designing Raman spectrometers. And those are devices used basically to measure light by wavelength. And you
Mm,
can use those to do all kinds of cool stuff. And I really like working in that industry. There's lots of really cool applications for that, from drug detection to,
yeah.
medical applications as well.
Yeah. Yeah, I mean, this is interesting too because like so you had another optics company on your thing. I mean, like in terms of like crossover, I wouldn't think, going from like a defense contractor specifically to an optics company, but like when you look at any kind of a system like this, it's like, all right, high speed signaling and FPGAs and stuff like that. It seems like, oh yeah, that starts to really match up.
Right. For example, there are lots of good reasons in an optical environment why you'd want to use an FPGA, mainly because the sensors require really tight timing, and maybe you could do it with a microcontroller and a real time operating system, but you probably need quite a beefy one. And FPGAs and CPLDs perhaps are really suited to that tight timing and parallel processing. So it's quite an interesting application for FPGAs, because most people, I think, consider FPGAs to be the workhorses of digital signal processing
Yeah.
and so on. Whereas this is much more about exploiting the tight timing relationships of clock signals to accurately move charge across a CCD, basically. So it's kind of really, really cool and
Yeah, that's
eye
great.
opening.
That's great. I mean, yeah, and I think any kind of like signal chain type stuff, usually signal chain or signal path type stuff. I started thinking maybe signal path is RF as well, but like FPGAs start to filter in the back of my mind as like, yeah, you're probably gonna start seeing those on a board.
Yeah, yeah, exactly. The interesting thing is, though, that FPGAs tend not to be very good at doing stuff like handling USB comms. I mean, it can certainly be done,
Hmm.
but most people know how to put down a microcontroller, and often the microcontroller is going to have a USB PHY built in. So, okay, now I've got USB comms. So, if you want to make a USB device that works with the CCD, most often you put an FPGA and a microcontroller in there.
Ah, gotcha. I mean, they're starting to smush those together a lot too, right? That's more common these days. But uh,
Absolutely, like the
yeah,
sync part that I think we mentioned before,
yeah,
and then
exactly.
you've
Yeah.
got Smart Fusion and all those others. But sometimes the problem with that is that you can end up with power density issues, and
Oh,
also a lot
interesting.
of those parts are meant for use, not for embedded systems. So if you're trying to make a system that's handheld or embedded,
Oh yeah,
battery powered or something like that,
battery. Yeah, battery
yeah,
backpack.
exactly,
Yeah,
yeah,
looking like a proton pack on your backpack.
yeah,
Uh,
exactly.
oh, interesting. I mean, it also kind of feels like Wasatch specifically, photonics in general, like it is kind of test and measurement as well, like just kind of these low volume, high specialized, that sort of thing. And now you're currently at Philips in the medical space as well, and that kind of again, it's medical now. We kind of wanted to talk about medical, and you had mentioned earlier, like medical kind of sometimes crosses over with defense as well in terms of regulations and stuff like that.
Right, and I think the medical industry is obviously a highly regulated industry. It's just different regulations, and the way those regulations get applied are slightly different. But for example, the FDA independently audits medical device companies and medical instrumentation companies, and the way in which you design the devices has to be done such that you can provide the evidence to the FDA that you've done your diligence
Hmm.
in your design. It's not. It will be no surprise to anyone if they, if they're not familiar with it, to see how it works. But it is diligent, it is stringent, and I am grateful for it, because we're all probably going to be patients at some point in our lives, and I
Yeah,
want
right,
whatever I'm
right,
hooked up to. I want to make sure that someone did their
right, right.
diligence. So
Yeah, it is definitely like a more kind of conservative design approach overall. You might not be on the hottest new part, you might not have the hottest new thing, but do you really care about that when you're hooked up to the machine? Oh no, this doesn't have Wi-Fi. Well,
well,
actually,
some of that's true, but
yeah,
actually, I
yeah.
found the medical device industry to be much more open to the use of newer technologies.
Oh, interesting. Okay, but is the FDA also in that camp or no?
Yeah, well, yeah, I think so. I mean, because
Huh.
it's not, the FDA is not really, they're not someone that I think that are going to prescribe to you what you must use. They're much more interested in prescribing to you the kind of diligence you have to do to prove that your device is safe.
Ah, interesting. Okay, so it's just tell them what you're gonna like any kind of like audit or ISO process type of thing where it's like you need to write down what you're going to do and then you need to prove that you did that sort of thing. And
Right. It's kind of like ISO on steroids, I guess.
yeah, yeah,
It's like,
yeah, yeah.
it's very much more involved than ISO,
Hmm.
because it has to be. But it is something that is geared towards making sure that something is diligently safe
Yeah,
at all
yeah.
levels. So it's less concerned with the implementation, and it's less concerned with the specific solution. It's more concerned with, given a certain solution, can you prove to me that it is safe? And so if you choose a technology that is hard to prove is safe, then yeah, that would make it difficult. But that doesn't preclude you from using
Ah,
newer technologies, so long as the
right.
way in which you do your implementation.
Right. And I imagine companies that are selling into that space too, they also have an onus of wanting to show the engineers that might design it in that it's, hey, look, this is easier to get through because we document X, Y, and Z and
That's
that
true.
sort of
I
thing.
think a certain amount of similarity can help.
Yeah.
The other
Yeah.
thing that I found is that a lot, and this is similar in the defense industry, I think a lot more time and effort is spent on I won't say doing things to death, but lots of analysis, lots of data
Ah,
to back up things, so for example, let's say in a startup you want to measure a signal, you pick an ADC that you think meets your spec and you put it on the board and okay, let's
way
go.
you go. Yeah, yeah.
Well, maybe here we'd pick an ADC in the medical device industry or defense industry, pick an ADC and it's got a spec on the data sheet, but we're going to test it and make sure that we're getting the spec that's on the data
Ah.
sheet.
And not just because you
Um,
have interns available, you're saying because it's a
right.
it's a cultural it's a cultural thing internally that it's a
Well,
good idea to just
the interns and
yeah.
co-ops got to do something. Yeah,
Yeah,
but
well, they're still gonna do it. I mean, let's be honest. I'm not doing it.
yeah,
I did that when I was an intern.
right. But it's more like I mean, you can imagine that it's not. I don't think it's that we don't trust the companies to overinflate their specs or something on the data sheet. That's not the case. It's
Yeah,
much more. You take a component and you implement it. Did your implementation cause a problem? Did you implement it correctly? Did you implement it in a way that wasn't quite how it was implemented and tested when the data sheet was written, and
yeah,
so on? So you can see there's lots of traps and pitfalls that you could potentially fall into.
yeah. That's interesting. Yeah, no, and actually, that is consistent with the my test and measurement equipment experience at Keithley. There was definitely that as well because it was like nobody's the only way you're going to find this otherwise if you're not testing it up front and have an ongoing like test process around it. You're going to find out the hard way by the it gets all the way to the customer and they say, hey, this isn't meeting specs because we're also testing our equipment. And so it's just like better to measure throughout the process. It sounds like then it's now codified, like the FDA is going to do some kind of testing along the way or verifying that you are testing along the way, but it becomes a cultural thing then internally at the company that testing is a way of covering for that eventuality.
Right. Right.
Yeah.
Exactly. I think that's exactly right.
When you go into an interview, so like because you kind of move between these different industries as well, when you go into an interview like with a Phillips in a medical space like that, do you talk about like, well, in the defense industry, I did this kind of process, and that's why I think like, do you try and make that connection yourself, or was it more like they were targeting because you had those past experiences?
No, I made that connection myself. So I'm I saw that I'd be interested in working with the medical devices because it seemed very different to what I'd done before, but also I could see that it was an opportunity to apply stuff that I knew how to do. So
Hmm.
a new
Yeah.
application of old ideas, I guess. And I assumed, and I guess I was correct, that if you've worked in heavily regulated industry, then a different set of regulations isn't really that difficult to come to terms with or understand or use. It can
Yeah.
be interesting, but you understand the concept. Whereas I know a lot of engineers that have worked in a lot of small companies and become aware through a chat over a beer or a coffee of the kind of things that I've had to do to satisfy certain requirements, and th- they at first are kind of like incredulous and oh my goodness, why would you want to have to do that? Which I can understand if it's not your thing, but also that they just weren't aware of that because they'd never had to. It never really occurred. Never had to
Mm,
think
yeah.
about that.
Yep. Yep.
So, I mean, the closest that really comes to is like CE marking and FCC marking, and that
Uh-huh.
honestly is for most devices is really not that hard and not that stringent.
Right. Yeah, I've talked about many times in the consulting space as well. Like I think when Charles was on Charles Aylward was on the show most recently, we kind of talked about this as well. Where like as a consultant, there by almost definition, there's nobody there to check your work, right? So you have to become that person that checks your own work, and like the best consultants, like Charles, I think, check their own work and they show they can do this kind of stuff. And one of the things that I was surprised by coming into that space was first off there was no safety net there, right? So you have to become your own safety net, and then when I learn about a new specification or requirement around that sort of thing, like a certification, it's like then you just have to learn how to become the specialist of that certification as well. And like you said, it's not like usually not overall this out of left field thing. It's just you need to know that you have to do it, and you have to go find the specification as it's written, and then you have to learn all of the nuances of it. But then once you have that, it's like, okay, now I know how to apply this.
That's definitely true, but I think there's a subtlety to it, and that is that one of the guys I work with now, he kind of has a mantra that two people working in a team are worth three. And I kind of think that's true. I think with the best will in the world, you can be a consultant trying to be diligently cross check and double check everything you've done and interpret things interpret standards, and you'll probably do a good job of it. But
Hmm.
when
Yeah.
there are other people with different perspectives that can challenge your ideas.
Oh, I have no doubt of that. I'm just saying in the scenario where you don't have that, you need to be at least as good as 1.5. I think like
Yeah, right.
I like yeah 2 is definitely that's a great maxim. I think
I think it's just that
sometimes you can't get it.
what I was trying to say is that that's a huge challenge. It's a
Yeah,
really huge
yeah.
challenge to work like that, and it's actually something that I personally don't enjoy that much.
Mm. Yeah, that's interesting. Yeah, I mean, especially because, well, like kind of we talked about ebbs and flows between bigger company, smaller company. Now, back in the bigger company, you do have, there's the downside of more people, more bureaucracy, more, kind of red tape. But the upside is more people checking your work. Especially that how that might play into younger engineers' experience as well. More people checking your work, more structure, that sort of thing.
Yeah, and more often than not, more ideas,
Oh,
more people trying to challenge your ideas.
I don't always want that, but yeah, I think at least a little bit of challenge is good. Yeah,
Yeah, I mean, I came from a place where I was the most senior engineer in a small company. While it was really good in some ways, in other ways, so it can be fun to have the responsibility of decision making for certain things, but it can also be a burden.
yes, yeah,
And it's good to have to not basically not be the biggest fish in the pond, I guess, if that makes
yeah,
sense.
yeah.
So I really like the idea that there are people that will, not to say that I rule with an iron fist or something, but
You heard it here, folks.
right,
Yeah,
exactly.
yeah,
But it's good. It's good when you've got different people from different walks of life and different
yeah,
engineering disciplines and more engineering disciplines in a bigger
yeah,
company, of course,
yeah.
coming to you with different ideas and trying to challenge your ideas and trying to make them better. So
That's
it
great.
kind of broadens your horizons.
Yeah, definitely. I think like you said earlier, I think having both in your experiences is going to enrich your abilities as an engineer and your job experiences. There's ups and downs to both, but it's best to just try it out and see what you prefer and where you are in life at the time.
Right, and if you prefer neither, I think it actually gives you a good. If you decide to go out on your own and
Yeah,
start consulting or something, I mean,
yeah,
if you look at any consultant that anyone has ever really hired, they didn't do that out of college.
yeah. Right.
They've gone and earned their stripes somewhere,
Yep.
and you have to do that.
Yep. Agree. Leigh, thank you so much for telling us about all this wide variety of experiences, and just I think your experiences have really spanned across industries and size of companies and cultures, and yeah, it's just been really really cool to kind of catch the ebbs and flows of your career and talk through them here.
That's great. Thanks for having me. It's been a pleasure.
Where can people find you online if they want to catch up more or see what you're working on?
Well, I'm on LinkedIn, Engineer Leigh, which
Yeah,
is
yeah, it's in the title.
easy to find me.
Yeah.
So yeah, and I hope to enjoy watching future podcasts from your channel as well.
All right. Thanks so much. We'll chat soon.
Thanks.